Absolutely. Okay. Record. All right. Recording has started. The floor is yours. The first 20 minutes is up to you. You can feel free to use it how you want. And then the last 10 minutes will be for questions. All right.
Okay, sounds good.
Excellent. Crush it.
Okay, so this is my project, my independent research project on automating FMS, specifically the overhead deep squat. So today I'm going to be discussing the video analysis and how I went about analyzing the athletes' videos to get a score, and then also the visualizations and results I was able to get from the video analysis. And finally, I started some recommendation systems, so I'm going to be presenting the beginnings of that. And then also, lastly, the challenges and future plans I have. So for the data, I took videos of 6 student athletes from the SCU women's water polo team, and I ended up using 5 of these athletes. Each of the videos had 5 squats from the front, from the side, and from the back, and I ended up only using the front and side videos because I felt like the back didn't have a lot of stuff to evaluate on. And then also I had CSV files that I was able to output from the Python package called MediaPipe, which was analyzing the videos. And these CSV files had the different angles from the videos so that I can plot the movement over time of each athlete from the front and the side. Other packages that I used were Pandas, NumPy, Matplotlib, and Seaborn to just visualize the data. Okay, and then before I get started, I just want to do a quick overview of FMS and what my project is trying to do. FMS stands for the Functional Movement Screen, which is a screening tool used to access an individual's fundamental movement patterns and identify limitations and asymmetries to help reduce injury risk. So my main goal was to use FMS in order to understand where athletes are lacking mobility and in turn provide them with training recommendations that help them improve their mobility. So I only worked on the FMS deep squat, and there's multiple other exercises which I plan on moving on to in the future. But for the deep squat, I basically evaluated it using the FMS criteria. Most of the criteria is being evaluated using the side view. So it was definitely one of the more important view out of the 2 views. So for the side view specifically, I'm checking for the squat depth, making sure it's below 90 degrees, and then also checking if the torso is parallel to the tibia, like this photo over here, or if the torso is almost vertical. I'm checking if the dowel is over the feet. Are the heels lifted? And then another thing I was checking for was knee forward travel, which is like checking if the knees are aligned over the feet or if the knees are going past the feet. I ended up removing this function because I was seeing a lot of errors when I was verifying the video. And then after I did some research, I did realize some people or some research papers were saying that it was not necessary. And then another function that I will talk about more later that I tried to implement but haven't been able to is the lumbar flexion or extension detection function. For the front view, there's not really much to check. I'm mostly just checking for valgus or varus in 2 different ways. The first way is checking for valgus and varus in relation to the knees and checking the position of the knees. And then the second way is checking the position of the knees in relation to like an imaginary vertical line in the middle of the person's body and checking if checking if the knees are going inward or outward. And then the last thing I check is foot alignment and seeing if the athlete's toes are pointing outward or inward. Okay, moving on to the actual video analysis, I'm only going to show one front view video because I mostly focused on side view since there was more criteria to look for there. So this is McKenna Jenko's front view. As we can see here, the first thing is that her foot alignment is failing because her feet are pointing outwards. Other than that, she doesn't show any signs of valgus and varus. So that was it for that video. And then every video has a score report. And so in this score report, we do see that the foot status is mostly failing. But it's also important to know that even though she didn't have valgus or varus, these checks for valgus and varus are like almost 50-50 pass and fail. I'll be talking more about this later. It's more of a technical issue. Okay, moving on to the side videos. I have multiple different side views to show, but let's start with McKenna's again. So for McKenna's video, we see that she isn't going the sufficient depth, and let me pause it at the deepest point. We see that she isn't going to the sufficient depth, which is below 90 degrees, but she is trying to go pretty deep. But to do that, she is leaning forward quite a bit. So the depth is failing, and to check for the forward lean, at first I looked at the torso tibia alignment. It's still borderline and it never fails. So it's either borderline or past, and it never fails. So that wasn't what was detecting the forward lean. We also see that her heel is lifting, and this function for the heel lift is not able to see that. And this is another technical issue that I will talk about later as well. But in general, when I first saw McKenna's video, this introduced a very big challenge throughout the project for me, which was evaluating what I call compensation patterns, where the athlete is doing like movements to compensate for their lack of mobility, but it's not explicitly failing the FMS criteria, so it's really difficult for the computer to detect. But by looking at the video by eye, we can see that something's wrong. And this issue became more apparent when I looked at Chloe Rizov's side view. So looking at her side view here, we see that actually she's passing almost everything except for the depth, and she doesn't really fail any of the criteria. But when she goes and squats down, we see that her back is really curved. And this wasn't something that I originally put in the FMS criteria, but noticing this compensation, I went back and did more research on whether or not something like this was in the FMS criteria, because clearly, even though it looks like she's passing everything, I don't think her score should be a 3 because she's like her squat pattern doesn't look natural. And the closest thing I could find for the FMS criteria was the lumbar flexion or extension. So I tried to create a function to check this. But then since MediaPipe uses only straight lines, it was unable to detect curves. And then lastly is Leah's video, and she's like a more unique case. Jake, I remember talking to you about her video some weeks ago, and you mentioned that although she's a great player, she doesn't have good mobility. But I feel like her video analysis didn't end up checking her lack, or like didn't end up summarizing her lack of mobility to the extent that it is. And I feel like a lot of this is because of the compensation patterns that I was talking about. It's like they're compensating their movements, they're compensating for their lack of mobility with movements that the computer is unable to check because it's not explicitly failing the criteria. So for her video, she's failing a lot more than Chloe is, but she's like swaying her arms around, and it looks like she has like some general like imbalance going on. So this was like the main part of my project where pretty much it was like a cycle of changing the code, verifying the videos to see if the results were accurate to what I was looking at by eye, and then finding some inconsistencies with the results, like I mentioned, like the compensation patterns, and then going back and doing more research on FMS and the criteria, and then reading research papers, and then finally just like repeating the cycle and going back and changing the code again and again. So this ended up using a lot of time, and I'm not sure if it was the best use of time because I ended up finding other types of data that could possibly give better results. But I think I still was able to learn about like the general human biomechanics, and it gave me some good foundation for the direction I should take my project in the future. So as I was saying, I spent a lot of time trying to get the accuracy up for the video, so I didn't really try to use a complicated algorithm to calculate the code, to calculate the score. I basically just calculate the number of fails, borderlines, and passes for each category. And then if any one category, if the fails in any one category is greater than 30%, the score is automatically 1. Otherwise, if any one category has a borderline percentage of greater than 50%, then the score is automatically 2. And if none of those are true, then the score is 3. So now a summary of the pros and cons of video analysis, or this specific video analysis. Some of the shortcomings here was that the inaccurate evaluations for some of the tests, like the heel lift. It also evaluates the movement while the person is standing, leading to some data contamination. So like we saw for McKenna's front view, it was evaluating her standing position as a fail, which doesn't make sense because she hasn't done any movement yet. So in the future, it would be a priority for me to only isolate the movement as the athlete goes down and reaches the deepest point of the squat and exclude their standing position from the evaluation. Also, the video moves pretty quickly, and I feel like it might not be useful for coaches to tell what's going on, so it's definitely not like a final product. And I think the biggest shortcoming is that it requires a lot of manual verification, which is very time consuming. And I have to keep going back to the video after every change in the code to make sure it's working properly. I do feel like there's some good strengths in this video analysis though, because it's very strict and it replicates what the actual FMS test was meant to be like. Also, when I was reading some research papers on why FMS is not good, some of the things that they mentioned was that it's too subjective and there's no score breakdown, so athletes can't actually tell what they're meant to do to fix their score or to improve their score. But the video analysis provides a completely objective scoring system and also gives a score breakdown, which fixes these issues. And I think there's a lot of potential for improvement as well once I get feedback from strength and conditioning coaches on what was accurate and what was not. Okay, next is the visualizations from the CSV files. I created one CSV file for the results of the video analysis. And so this is just a big picture overview of all the results from the video analysis and every person and the score that they got for each category. Obviously, you can't really tell much from this until you can't really tell if this is accurate or not until it's been verified by professionals. But looking at the patterns, I can see that the torso and tibia category and the heel lift category are all passing for all athletes. And it seems a little suspicious. Also knowing that heel lift doesn't work properly, I would also be suspicious of the torso tibia alignment, and I'd want to check to see if that's working properly as well. And because of the data contamination, we see that the front view is mid-range to really high failure. So this, I feel like the heat map right now can't tell much, but after improving the video analysis, I think it can be a good visualization. Some more interesting visualizations I created were these ones where they basically map out the hip angle and the knee angle and also the torso angle. So the torso angle is this red line over here, and the hip and the knee are the blue and green lines. So for McKenna Jenko, we see that her torso lean peaks before she reaches the lowest point of the squat. So this kind of suggests that she's leaning forward excessively to achieve this depth. And this is absolutely true when we saw the videos. And then if we go down to Leah's, we see that her torso lean peaks right at the deepest point of the squat. And this actually suggests good movement or a good movement pattern, which shows that I'm dealing with the same issue of being unable to track the compensation patterns that athletes are doing. Chloe's is also similar to Leah's, where she's having a good movement pattern, especially compared to Jenko. It's a pretty good movement pattern. So again, it's hard to track compensations that the athletes are doing, especially the curvature of her spine. But I still think if I dig deeper into the data, I'll be able to find some results to show that they're making these compensations, because we can see there's some wobbly lines over here for Leah's, and we also see these humps that no one else has in Chloe's torso lean. And then I also have McLaughlin's graph over here. I didn't show her video. The reason is because I took her video on a different day. And on that day, all the athletes that I took a video of, I was like standing a little closer to them, and the perspective ended up being a little bit off. And I didn't want to use those videos, which is why I excluded them from my analysis. And we can see that it's like really wobbly over here, and there's a lot of noise. So I think it's a good idea that I excluded them from my analysis. Okay, the next graphs that I have are this movement compensation analysis. This one shows that as the athletes squat deeper, their torso lean becomes more prominent, and there's a very clear inverse relationship with the hip angle and the torso lean. So it kind of shows that many of the athletes that I checked are leaning forward more to compensate for their lack of mobility elsewhere. And then one of my main goals for the project was to categorize the athletes in order to help the coaches decide what training they should do. This kind of does that, but with the video analysis data I have, so it might not be so accurate, but it shows that Chloe and Leah have only lower body dysfunction, while everyone else has like universal body dysfunction between the lower and upper body. So again, I feel like the video analysis wasn't able to capture the compensations they were making. Now I'm just going to quickly go over like the beginnings of a recommendation system that I have planned. I did write code for this, but it gives the same output for every single athlete since they all had insufficient depth. But basically what I'm doing is it's a rule-based recommendation system. So it just checks to see if the hip angle is over a certain amount of degrees, and same with the torso lean, and the asymmetry and fluctuation. And I chose this over machine learning because if I chose to do machine learning, I would need a lot more data, which is probably not available, and I'd have to create my own data set. So I think for now, this is a good type of recommendation system that I should do for the future. Now for the challenges that I faced, starting with the strength and conditioning challenges, the strength and conditioning challenges. As I mentioned before, the videos were like in different perspectives based on the way I took them, and that kind of led to like a lack of data for me. Another thing was not being able to track the compensation patterns, as I've been mentioning throughout the presentation. And the reason is because they're different for each person. And I don't want to go and find every possible compensation pattern that can exist because I feel like it would over-engineer the video analysis and it would just not be as accurate. But other things that I was planning on checking was the momentum changes as one goes and drops down into a squat. And also, as I mentioned before, the spine flexing or extend. Sorry, I'm in the library. But as I was saying, another compensation pattern is the spine flexing or extending. And then lastly, overpronation, which is shown here. All of these challenges ended up being technical challenges as well because I had trouble implementing or fixing the issues. But the main technical challenge out of everything was the limitations with 2D media pipe and its lack of accuracy with specific functions. For heel lift, since media pipe only tracks the person's body movements and not the ground, it's unable to see if the person's like foot is coming off the ground. And then for lumbar flexion or extension, because the lines are straight, it's hard to detect curves. And then for the side views, for the lesser visible side, for example, if someone is facing right and I'm videotaping them from the side, the left side is less visible and media pipe is unable to get the coordinates of the left side accurately. So getting asymmetries would be difficult with video analysis. I still feel like this project has a lot of potential and it could be really interesting. So some of the technical changes that I want to make is replacing the 2D media pipe with like a 3D video analysis open source library or something else that would more accurately get the angles of the person's movement. I also want to dive deeper into the CSV files outputted from the video analysis because I think some of the visualizations show things that the video analysis cannot detect. And my ultimate goal would be to have all the videos for one person of them doing all the different FMS exercises and be able to output a comprehensive list of training recommendations based on their weak points. And then some practical changes that I want to make is set up a tripod in order to make sure videos are consistent. And then I also want to talk to Jake and other strength and conditioning coaches to make sure that I iteratively refine the video analysis, the score calculation, and the recommendation system. Yeah, but that's it. Thank you.
Are you serious? This is legendary. All right. Let's just get to the. Are you coming? Are you willing and wanting to come back and join us again next quarter?
Yes, for sure.
Okay. I would like to implement this with both of my teams week one. Okay. And so what I mean by that is my next set of questions is going to be future planning and less about the project. Does that make sense? Because your project is spot on. I also think that some of the lumbar flexion, some of the thoracic mobility issues that are taking place, I don't think those can be quantified how we think they can. I think that is something we can pursue, but I feel like it's going to take a different transition. But what I think we can also do is as we get these results is it's not going to be a direct plug and play, but as we talk about the individuality, we can assign exercises or movement patterns that will help address an influence based upon the individual person size of it. So like how I give out corrective cards is it wouldn't be necessarily a corrective card as in like you've got these 5 exercises to do, but rather it will direct the exercise within the corrective card. So someone would be doing like, let's say 3 sets of 10 of thoracic extension, which would be card 1, exercise 3, versus another person may be doing what we call 90-90 T-spine, which would be card 1, exercise A, 3 sets of 10 within the movement of, let's say, a power clean, because that's going to be more dynamic, which will then carry into the squat pattern. But I think this is a huge tool that we don't have that I would like to see how it plays out. So how do you feel about that first week? We'll sit down and we'll put together a schedule, because some of the other questions I have is how often do you test this?
I just test it every time I update the code. Like I didn't have a lot of data to go off of, so I would just change the code and then go back to the video, see if it looks right, and then like just continue from there.
Okay, perfect. So then with that knowledge and then us filming it one time, what
Hmm.
would be the frequency of re-recording a video of an athlete?
Um, I think like we wouldn't need to re-record it from like a technical standpoint because if the video is good enough, then like any changes to the code will map onto that video. But I think if we want to see how the athlete improves over time, we should like record videos more often. But I think that's a question that I'm not sure how to answer. Maybe that's like more of a strength and
Okay.
conditioning.
I agree with you on that 100% because I think we should do it once a month. And what we do is we pick the date that works best for you. And so, like, it can be any date we see this, because I also see how you interact with us next quarter is going to be very different and less strict of like in class time, more of an operational procedure of
Yeah.
you implementing and doing it. So, like, let's say we go every like third Thursday of a period. So like every third Thursday, we would say, all right, we're going to put women's water polo through this, or we're going to put just depending upon time. Maybe it's every third Wednesday, women's soccer. Hey, we're going to film this. Because then my next couple questions is like, all right, we get the footage. How long does it take you to put it into the system and grid it?
It doesn't take very long. I just have to put the video into the folder and then that's all.
It's that fast.
Yeah, it takes like 10 minutes to process.
Do you realize what you just created?
But the thing is, I'm not sure if it's so accurate, and that's why I wanted to.
Well, that's the point. We just need to put humans into it.
Okay.
You get what I'm saying? Like I agree with you. Like I think the CSV, from reading it, I agree there's some errors, but I think it's because we have a lack of data.
Okay.
You know what I mean? And so like some of the things, like I agree, absolutely agree with your analysis of Leah. I agree with your analysis of Chloe. Like you're spot on. I think it then becomes the next step would be is all right, as the person adapts and gets better at movement, okay, the program has to reflect that change. And that's where I think the strength and conditioning coach, because like what I would do is going to be very different than what our basketball strength coach is going to do. So there's nothing wrong with it because I mean ultimately you're going to get to the same result. The question then becomes as we start to put athletes into it, it's more the battle of time because we are limited on time. But I think you're really onto something special. And like I said, it's affirming, reaffirming, or directing what we already do. Does that make sense?
Yeah.
So, yes, you've created a tool that will show us a lack of pattern, show us a lack of movement, but also on top of that is an injury prevention tool because if we read it how it's supposed to be, we can prescribe exercises to align with what the video is showing us. Okay.
Hmm.
And again, it's not that we're using it to make better squatters. We're using it to make better movers. So there are things that naturally happen in a squat pattern that we wouldn't want them to test on during this test. For example, on a back squat, we would want the toes to be out. And a lot of that is to make sure the knees stay out and they squat on the outsides of the feet, which allows their hips to open up, but it also gets more muscle contraction and allows the body to become more stable with more co-contractions in the muscle. With an overhead squat with no weight, we don't want that. We want them to be able to move as a unified object. And I think your system does a great job of saying yes or no. Now,
Yeah.
as far as the gray area that you brought up, there has to be a little bit of intuition. And so I think your concept of like moving forward, of prescribing or recommending, I think that's a great idea. But I think the recommendation is a little bit more on the front end work of someone like me so that your system can say, all right, here's your pattern. Here are the exercises you use versus like if you were to train somebody, here's your pattern, here's the exercises you like. Does that make sense?
Yeah. So basically, what you're saying is that this should be more of a tool for you to be able to recommend proper exercises for the athlete.
Yes and no. Yes, but what I think it is more of an identification tool to
Hmm.
say here's the recommendation, like here's global problem. All right, out of
Yeah.
this global problem, then Jake would plug in his exercises. Okay. And then
Mhm.
what that does is it says yes. And then in that little chart, it will say card A, exercise one.
Okay.
Does that make sense?
Yeah, I think that makes sense. I think,
Yes.
yeah, go ahead.
Well, I was going to say too, like the fact that you were able to take a video on your phone and then put a system on it and you got numbers, like in doing so too, as I'm watching this and I'm seeing it, you are giving value to a lot of the things I talk to our athletes about in a visual perspective that I can't give. Okay.
Hmm.
And so it really excites me because then it puts me in a position to not only say I knew I was right, but also it leads me to the next step of, all right, I know I'm right. It's not a time to brag. How do we adjust it? And then how often do we have to adjust? Does that
Hmm.
make sense?
Yeah.
Yeah. And I found a tripod for you.
Okay.
Yeah.
Yeah, I
So
think
yeah, go ahead.
yeah, what I want to do the first week is, as you said, like create a schedule, but also start taking the videos as soon as possible because it's very likely that I'll have to like retake it multiple times to make sure the perspective is like consistent with all the videos. Like find like the right perspective to do.
Correct. And I also think too, I do like your assessment of the front and back, where the front tends to be more lower half versus the side view. You do get a global view, which is really great. I agree 100% on that. Um, so I think also in doing so, all right, moving forward again, not only do we build out the template that gives us the result of the video, but also putting in together a protocol of like, what does that look like? Like, is it 5 reps? Is it 3 reps? And then
Mhm.
also on top of that, like, do we do exercises before or do we do it raw? Like these girls, they were just walking in and we had them do it. In my opinion, doing an FMS, that's how you do it. Does that make sense? So if that's the case, all right, this is something we need to put in place, but also are there coaching cues? Are there no coaching cues? So I think this is going to be something that we're going to have to sit down and write like week one, but then also as we develop that into week one, we're going to take videos as soon as that makes sense for us. Okay.
Mhm.
And then it becomes also how do we set up the tripod? Do we use an iPad? Do we use a cell phone? Um, and marking it out on the floor. Because I do think, like looking at your videos, I kind of think the grid gets in the way.
Yeah.
You get what I'm saying? Remember when we filmed in front of that grid? Because I really like the way how easy it is to see. I think the grid makes it too congested.
Yeah, when I used the grid, I think like I was standing a bit too like it was a small area, so then also I had to stand closer to the athletes. And then there's just so much stuff going on in the background. I'm not sure if it confused the thing I was using to train the video analysis with.
Yeah, this is a really cool project and tickle me impressed. You did outstanding. Um, I hope you shared it with your uncle. I hope he was able to take a look at it too.
Yeah, yeah, I'll share this presentation
Yeah,
with.
yeah, because this is really cool. You did something really impressive, and I'm
Thank,
excited for next quarter because we're gonna
thank
do this, and we're gonna work with both teams, women's
you.
water polo and women's soccer for sure. I'm gonna try and get some other teams on board, and then what we can also do is look at putting this on paper as far as a protocol, and then we get to have the fun stuff with the video of what does it look like at the end, like what do we want our report to look like.
Yeah, sounds good.
Awesome job, great job, and by the way, I can't wait to share this with the staff.
Thank you. I'm very
Yeah,
excited.
good job. Oh man, this is a great day. Oh, thank
All
you,
right,
and
I'll see
have
you
it.
later.
See you later. Enjoy your finals and then enjoy your break.
Thank you. You too.
Bye.
Bye.